Hello everyone, my name is Mustafizur Rahman, a final year PhD student at the University of Texas at Austin. I am glad to present our CVPR highlight paper, EffiDec3D, an optimized decoder for high performance and efficient 3D medical image segmentation. Before going to present our core contributions, let's start with what is 3D medical image segmentation. It is the process of automatic labeling of organs, lesions, tumors, or other biomarkers in volumetric CT, MRI, or other medical imaging modalities. Now the question is, why do we need 3D medical image segmentation? 3D medical image segmentation has significant clinical value because it is a critical step in accurate disease diagnosis, surgical planning, and treatment monitoring. The recent state-of-the-art 3D segmentation networks, including SwinUNETR, 3D UXNet, MedNext, have shown high performance. However, they need large memory or compute resources, which limits their real-time use in point-of-care and low-resource settings with limited to no GPU access. Therefore, it is critical to introduce high-performance yet computationally efficient method for 3D medical image segmentation. Addressing this need, we introduced EffiDec3D, a plug-and-play decoder optimized for computational efficiency without sacrificing segmentation performance. Our method has two parts. First, systematic computational complexity analysis of existing architectures to find out bottlenecks for high computational needs. When we analyzed the 3D UXNet architecture, we found that decoder is the main bottleneck. It brings more than 98% of parameters and flops. And inside the decoder, high resolution decoder stages introduce high flops, about 60% of the flops of the decoder. We introduce resolution restriction strategy to optimize flops as it does not drop the accuracy much, rather sometimes improves in comparatively less complex datasets. We also found that excessive numbers of channels in low-resolution decoder stages are responsible for high parameter counts. About 87% of decoder parameters, we introduced a channel reduction strategy to optimize the number of parameters. This is our optimized architecture. Where using the resolution restriction strategy, we remove high-resolution stages and output at half resolution. While using the channel reduction strategy, we set uniform number of channels in all decoder stages to the minimum number of channels across the encoder stages. If we see the bar plots at the right side, we can see that our optimization reduces the number of parameters and flops 100% at high resolution stages, while achieving more than 92% reduction also in low resolution stages except half resolution stage. Consequently, our optimized EffiDec3D decoder achieves 93% reduction in flops and 96.4% reduction in parameters. We optimized 4 networks such as SwinUNETR, SwinUNETRv2, 3D UXNet, and MedNext using our EffiDec3D decoding. We can see that our EffiDec3D optimized versions of these networks achieve up to 96.4% reduction in number of parameters and 93% reduction in number of flops compared to the original decoder, with only 0.4% drop in dice score on BTCV13 organ segmentation. The qualitative results also show that our EffiDec3D optimized models produce comparable segmentation output in first example, top 2 rows. In the second example, bottom rows, we can see that UNETR, NNformer, UNETR++, SwinUNETR, SwinUNETRv2 cannot segment the esophagus, while our EffiDec3D optimized models can segment some parts of the esophagus, which highlights better segmentation accuracy of our models compared to the original ones. The key takeaways from our paper are as follows. We introduced EffiDec3D, a fast, lightweight, and accurate decoder for 3D medical image segmentation. Our EffiDec3D decoder can be used as plug and play with different existing networks, including but not limited to 3D UXNet, SwinUNETR, SwinUNETRv2, MedNext. Our EffiDec3D achieves up to 16.8 times reduction in parameters, 12.3 times reduction in flops, 4.5 times reduction in GPU inference time, and 8 times reduction in CPU inference time. We evaluated our EffiDec3D optimized networks on 13 tasks, including BTCB 13 organ, BTCB 8 organs, theta, and 10 MHD tasks, where our EffiDec3D optimized models increase the DICE score up to 1.33% on an average on 13 tasks. We can see significant improvement in binary segmentation tasks, but marginal drops in complex multi-class tasks. Please visit our website for more details. Thank you for listening. As I wrap up, I would like to share that I will be entering the 2026 job market seeking tenure track or research scientist roles in AI for healthcare, medical imaging, or computer vision. If you know of opportunities where my expertise can add value, I would welcome the chance to contribute. Please feel free to reach out. Thank you once again.